Hi everyone! Today we will be solving electrical circuits using MATLAB. My name is Gloria Sanchez and I will be presenting today with my teammates Eric Mathews, Jennifer Tran, and Joceline Zavala. Today we will be discussing electrical circuits. We will begin by providing an example of a parallel circuit and discussing how MATLAB can be used to solve for its resistance. And we will end this presentation today by discussing nodal analysis and how MATLAB can be used for that as well.
Hi everyone, I'm Joceline and I will be introducing you to electrical circuits. A circuit is like a never-ending loop that provides a complete path for electricity. A circuit consists of four major components, which are a battery, a conductor, an electrical load, and a switch. The battery is the main energy source that provides the voltage and the current that gives energy to the device that is attached to the circuit. The conductor provides the path for the circuit, such as a wire, and the electrical load is a device that uses a power such as a TV, a phone, or a light bulb. The switch is like the control center that closes and opens the electrical energy flow. There are two major types of electric circuits, a series circuit and a parallel circuit. A series circuit consists of loads that are connected in a series one after the other without the wire branching. If one load does not work, then the rest of the loads will not work. On the other hand, a parallel circuit consists of different branches or parallel paths in which electricity can flow. If there is a break in the path, or if one of the loads does not work, the current can still flow in the other branches. The voltage of a parallel circuit remains the same anywhere in the circuit. The total current is equal to the sum of the currents that flow through each path. The resistance is the sum of the reciprocal of each resistor. And as you can see, we have an equation on how to calculate it. And when there's only two resistors in parallel, there's an easier way to calculate it.
Here is an example of a series parallel circuit. Next, we will be discussing how to use MATLAB to solve for its total resistance. We begin our MATLAB code by creating a new function from the File menu. Our input variables will be our resistors. Output variable will be our total resistance, and we will name our function parallel. We define our function as follows. Function R total equals parallel, parentheses resistor 1, comma resistor 2, parentheses. Next line is R total equals the product of our resistors divided by the sum of our resistors. After we save our function, the next step is to go to our command window and begin by adding value to our resistors based on our circuit provided in the previous slide. Afterwards, we invoke our function that was saved by typing in R total equals R1 plus parallel, parentheses, the series of resistors that were in parallel. Note that R1 is one of the resistors that was not in parallel, but it also is within the series, so that one was added separately. And as a result, our total resistance is 4.
For this next example, we're going to be using nodal analysis. Nodal analysis can be used to solve complex circuits by using the node voltage as the circuit variables. The nodes of the circuit are the places where they connected together. Analyzing the connected circuit containing nodes will require us to use the KCL equation. The KCL equation can be found from each node with the exception of any reference or datum nodes. The following steps are used to determine the nodal voltages. First, you have to express the element current as a function of the nodal voltage. Next, you have to apply KCL to each node with the exception of reference nodes and datum nodes. And finally, you have to solve the resulting equations to obtain the unknown voltages. In MATLAB, the two methods used to conduct nodal analysis are using the circuit equation solver or the matrix method. For the next example, we'll be using the matrix method to solve nodal analysis. This is the following circuit that we'll be conducting nodal analysis on. There are three resistances displayed on the circuit. R1, which is 10 ohms, and R2 and R3, which are both 7 ohms respectively. There are two current sources, I1, which is 4 amps, and I3, which is 2 amps. Using the matrix method, we will be solving the unknown voltages on this circuit. The MATLAB solution to solving nodal analysis via the matrix method is using two input variables R and V, one output variable I, the function name of matrix. The script purpose is allowing you to apply KCL by utilizing the matrix function in MATLAB. In the command window, on the first line, we do CLC, semicolon, R to set up the first matrix, 0.2428, negative 0.1000, semicolon, 0.1000, and negative 0.2428. V, which represents the second matrix, is 2 and negative 2. To solve for I, you need to find the inverse of matrix R multiplied by matrix V. And finally, to receive your answer, we use the display I, which is the result of the multiplication of the inverse of R times V. The results we get are V1 and V2, which is represented by 14.0056 and 14.0056 respectively.
In conclusion, MATLAB can be used to efficiently and accurately solve the electrical circuit problem two different ways. For a series of parallel circuits, we need to create a function to find the total resistance, or R total, of a series parallel network using the following equation. Total resistance is equal to the product of resistance 1 and resistance 2 divided by the sum of resistance 1 and resistance 2. The second method we looked at today was for nodal analysis. For this, we can obtain any unknown voltages by expressing element currents as a function of the nodal voltage. Then we create the simultaneous equations and then solve them by using the circuit equation solver or the matrix method in MATLAB. We could also solve these by using a calculator. However, these methods would not be as efficient as using our MATLAB programs that we talked about today.